In this video, we're going to talk about the addition rule, which is used to find the probability that an event A or B occurs. So given two events A and B, we want to find the probability that A or B occurred. And in math, we mean inclusive or, so that means at least one of the events A or B occurred. So it could be that A occurs, or B occurs, or both occur. And this probability is denoted P, A, or B. It's also denoted probability of A union B. We'll primarily use this notation in the course. So here are just two examples to get you started. There are 52 cards in the standard deck. There's 13 of each of the 4 suits and 4 of each rank. So if you choose one card from a standard deck, first of all, what is the probability that it is a queen or a jack? And second of all, what is the probability that the single card you choose is a queen or a heart? So try thinking about each of those, and we'll talk about them in the next slide. Okay, so finding the probability that the card is a queen or a jack. There's different ways that we could do this, but the probability that the card is a queen is 4 out of 52. So that's for being a queen. The probability that the card is a jack is 4 out of 52. And so the probability that it's one or the other or both, well, a card cannot be simultaneously a queen or a jack, so we don't have to worry about the both possibility. But this is going to be just the sum 8 divided by 52. That should be fairly clear, but just to remind ourselves, this is number of ways that the queen or jack can occur, divided by the total number of simple events, the number of ways to draw the card. So 8 out of 52 is our solution. How about the probability that the card is a queen or a heart? Well, we have 4 queens, we have 13 hearts, but we have one card that is both a queen and a heart. We have one queen of hearts. So when we think about trying to use something like what we did above with addition, 4 out of 52 is the probability that it was a queen. 13 out of 52 is the probability that it was a heart. But we need to subtract off 1 out of 52. This is the queen of hearts, because this queen of hearts was counted twice. It was counted as being a queen and it was counted as being a heart. So if we don't subtract off, we will have double counted the possibility that the card is both a queen and a heart. Another way of thinking about this is just to say, okay, there's 4 cards that are queens. There are 12 additional, so there are 12 additional cards that are hearts and not queens, divided by 52 cards total. And this would give us the same solution of 16 out of 52. So in either case, your answer should be 16 out of 52 for the probability that the card is a queen or a heart. So this leads us to our statement of the general addition rule, that the probability that A or B or both occurs is equal to the probability that A occurs plus the probability that B occurs minus the probability that both A and B occur. So up here, this was the probability of a queen was 4 out of 52 plus probability of drawing a heart was 13 out of 52 minus the probability of drawing a card that was both a queen and a heart was 1 out of 52. And that gave us the probability of drawing a queen or a heart. You can, of course, also think about this intuitively, that the probability of A or B is the probability that at least one of the events A or B occurs, where no event is double counted. So subtracting off that probability of A and B is subtracting off the circumstance where all the circumstances where both A and B occurs, because again, these events are counted in A and they're counted in B, so they are counted twice unless we are careful to do something about it. Let's look at another quick example. So 400 travelers were surveyed. 80 had been to Mexico, 90 to Hawaii, and 20 to both Mexico and Hawaii. If a random traveler from this group is selected, what is the probability that they'd been to Mexico or Hawaii? So this is a place where English is a little bit non-specific, but in math, when we see something like of the above, 80 had been to Mexico, 90 had been to Hawaii, and 20 to both, will always mean that the 20 people who'd been to both Mexico and Hawaii are also counted in that original group. So in math, it's, has that person been to Mexico? Yes, if they've been to both Mexico and Hawaii, we would count them in the group of people who had been to Mexico. So the 80 people who've been to Mexico includes the 20 who've been to both Mexico and Hawaii. The 90 people who've been to Hawaii also includes the 20 people who've been to both Mexico and Hawaii. So with that in mind, try that problem out. If a random traveler from this group is selected, what is the probability that they'd been to Mexico or Hawaii? All right. There's different ways we could think about doing this. One is to think about like a little Venn diagram and to say, well, there are 20 people who had been to both Mexico and Hawaii. There were 80 people who'd been to Mexico, but there are 60 who have been to Mexico but not Hawaii, because in total, 80 minus 20, 60 have been just to Mexico. And similarly, 90 minus 20, 70 have been just to Hawaii. That's out of the total of 400 travelers in this group. And so that would give us 60 plus 20 plus 70 over 400. That would give us 130 plus 20, 150 out of 400 is the probability that a traveler had been to Mexico or Hawaii. That would be one way of approaching that, not specifically using the addition rule above. Another way to approach the problem using the addition rule would be to say, okay, probability that the traveler had been to Mexico or Hawaii is the probability that they'd been to Mexico plus the probability they'd been to Hawaii minus the probability that they'd been to both Mexico and Hawaii. And so that would be 80 out of 400 had been to Mexico, plus 90 out of 400 had been to Hawaii, minus 20 over 400 had been to both. And so again, that gives us 80 plus 90 is 170, minus 20 is 150 over 400. So that would be our final probability in either case, the probability that the traveler had been to Mexico or Hawaii.